I kept her steady as we slipped below formation, engines still turning, the sea waiting beneath the cloud. The instruments flickered, and the radio gave me nothing back. The orders were clear: hold position, maintain course, but the system inside my own aircraft had begun to fail me. I watched the altimeter and trusted what I could hear more than what I could see. By the time I understood the descent, the horizon was already gone. On 23 March 1944, a United States Army Air Force's B-24 Liberator departed from RAF Horsham St. Faith in Norfolk, England, as part of a routine heavy bombing mission over occupied Europe. The aircraft belonged to the 458th Bombardment Group, 8th Air Force, which by that stage of the war had been conducting sustained daylight operations against industrial and transportation targets inside the German Reich. Allied air planners were focused on crippling fuel production and railway infrastructure in preparation for the anticipated invasion of Western Europe later that year. Losses remained significant, but procedures had become standardized and crews were accustomed to strict formation discipline. The Liberator in question, serial number 4294917, had completed multiple sorties since arriving in Britain the previous autumn. Maintenance logs from the group engineering section recorded no major structural concerns in the weeks leading up to the mission. The aircraft's 4 Pratt & Whitney R-1830 engines had undergone routine inspection, and the hydraulic systems had been serviced following minor leaks common to the type. Weather briefings that morning described high-altitude cloud cover over the target area, but no severe storm activity along the outbound route. The pilot, First Lieutenant Harold W. Givens, was 26 years old and had trained in Texas before being assigned to the 8th Air Force. His crew consisted of 9 other enlisted men and officers: a co-pilot, navigator, bombardier, radio operator, flight engineer, and gunners stationed in the nose, waist, ball turret, and tail. By early 1944, such crews had typically flown between 10 and 15 missions together. They operated within a well-defined hierarchy and relied heavily on checklists. Surviving correspondence from Lieutenant Givens suggests a methodical temperament rather than a reckless one. He wrote frequently about engine management and fuel consumption, rarely about heroics. At 8:17 hours, the Liberator lifted from the runway and formed up with the remainder of the squadron. The climb to operational altitude was uneventful. Formation spacing stabilized as the bomb group crossed the English coastline. Radio discipline was maintained, with communication limited to essential navigational corrections and engine reports. German fighter activity in that sector had decreased slightly during late March, though anti-aircraft fire around primary targets remained heavy. Approximately 90 minutes into the flight, while still over the North Sea and before reaching the European mainland, several aircraft in the formation reported intermittent instrument irregularities. These were not unusual at high altitude. Icing conditions could affect pitot tubes, and electrical fluctuations occasionally caused minor compass deviations. According to post-mission debriefings from other crews in the same group, there was light turbulence at around 18,000 feet, but nothing outside expected parameters. At 09:46 hours, ground observers along the Norfolk coast reported seeing a single B-24 leaving formation and descending gradually. The aircraft did not appear to be trailing smoke. No parachutes were immediately visible. Radar coverage in that area was limited and often imprecise, relying on early warning stations designed primarily to detect incoming enemy aircraft. Records from the Fighter Command Sector Station indicate only that one friendly heavy bomber observed losing altitude in a controlled manner. Within the Liberator, there is evidence of a developing systems concern rather than catastrophic damage. Fragments of the aircraft later recovered suggested that the landing gear had not been deployed and that the bomb bay doors remained closed. The propeller blades of at least 2 engines displayed signs of rotation at impact, indicating that power had not fully failed across all engines simultaneously. Testimony from a nearby Royal Air Force Coastal Patrol crew provides the only external observation before the crash. Flying at lower altitude on a routine convoy escort, the RAF pilot noted a four-engine bomber descending at what he described as a shallow, steady angle. He observed no evasive maneuvers and no apparent attempt to ditch at sea. Within minutes, the aircraft struck the water approximately 15 miles east of Great Yarmouth. Rescue launches were dispatched from the coast, but debris fields in the North Sea were difficult to navigate. Oil slicks and floating fragments were located by early afternoon. No survivors were found. All 10 crew members were later listed as killed in action. Initial assessments treated the event as a probable mechanical failure. The B-24 had a known vulnerability in its fuel system, particularly in cold weather conditions where fuel lines could constrict. Additionally, the type's Davis wing design, while efficient for range, could be structurally stressed if subjected to abrupt turbulence. However, no distress call had been logged by radio operators at base. The absence of a Mayday transmission raised questions among group commanders. Standard investigative procedures required collection of maintenance records, crew training histories, and meteorological reports. The 458th Bombardment Group engineering officer submitted documentation confirming that 42-94917 had passed its last inspection without major discrepancies. Fuel loads were within prescribed limits. Bomb load configuration was standard for the assigned target. Weather data from coastal stations indicated air temperatures at altitude of approximately minus 15 degrees Celsius. Icing was possible but not extreme. Other aircraft in the same formation completed the mission and returned without reporting severe system anomalies. No enemy fighters were reported in that sector during the time frame in question. One complicating factor was the limited wreckage recovery. The North Sea's depth and currents hindered extensive salvage operations. Only scattered components were brought ashore, including sections of fuselage skin, a damaged altimeter housing, and personal effects belonging to the navigator. Without a largely intact airframe, structural failure could neither be confirmed nor ruled out. Within days, the incident report was categorized as cause undetermined, presumed mechanical malfunction. Such designations were not uncommon. The pace of operations in early 1944 left little room for extended forensic inquiry, especially when no clear evidence of enemy action existed. Loss statistics were compiled, next of kin were notified, and replacement crews arrived from the United States to fill operational gaps. Yet within the group, there were quiet discussions about the absence of visible fire or explosion. Crew members who had flown alongside Lieutenant Givens remarked that his aircraft had appeared stable, though slightly below formation, before descending further. One waist gunner recalled noticing a subtle change in the Liberator's attitude, but could not specify whether it was a banking maneuver or gradual pitch adjustment. The B-24's flight engineer position was responsible for monitoring engine performance, fuel mixture, and manifold pressure. In emergency procedures, engineers were trained to feather propellers in the event of engine failure and to redistribute fuel from auxiliary tanks. The evidence that at least 2 propellers were rotating at impact suggests that some level of engine power remained. This detail complicated assumptions of total engine loss. Operational doctrine emphasized maintaining formation unless damage made continuation impossible. Leaving formation exposed a bomber to enemy fighters. The fact that the aircraft separated over friendly territory suggests that Lieutenant Givens recognized a problem early and chose to turn back before crossing into heavily defended airspace. That decision aligns with standard safety protocols. However, the lack of a radio message remains unexplained in official records. The radio operator's transmitter was among the components not recovered. It is unclear whether electrical power was compromised. The B-24's electrical system depended on engine-driven generators. Partial failure could affect communication without immediately disabling flight controls. As March 1944 progressed, the 8th Air Force intensified operations against transportation networks in France and Germany. losses from flak and fighters dominated casualty reports. The disappearance of 42-94917 received limited attention beyond its unit. Its classification as mechanical malfunction allowed the group to move forward operationally without revising tactical procedures. For the families of the crew, the distinction between enemy fire and mechanical failure had little practical meaning. Official telegrams cited, "died in the service of his country." Burial arrangements were delayed due to the absence of recoverable remains. Memorial markers were later placed in American cemeteries in Europe. In the squadron's daily logbook, the entry for 23 March occupies a single line. One aircraft failed to return, cause unknown. There was no annotation suggesting sabotage, weather anomaly, or collision. No other aircraft reported mid-air contact. Formation spacing that day had been typical. The event might have remained a minor statistical entry in wartime records. Yet in subsequent months, as more B-24 crews reported subtle instrument irregularities over the North Sea, engineering officers revisited earlier incident files. Patterns were difficult to establish. Reports varied in detail and reliability. Wartime documentation was often incomplete. By the end of spring 1944, Lieutenant Givens's aircraft remained officially categorized as lost due to undetermined mechanical causes. No formal board of inquiry reconvened to re-examine the case. The demands of the approaching invasion absorbed administrative attention. The story of 42-94917, at that stage, rested in archived maintenance sheets, brief eyewitness accounts, and the quiet recollections of men who had watched a bomber descend steadily toward the sea without visible damage. It was a loss recorded, processed, and operationally absorbed, yet not fully explained within the technical understanding available at the time. By late April 1944, the tempo of operations from eastern England had increased further. Bomb groups rotated between targets in occupied France and deep strikes into Germany. Aircraft losses were analyzed primarily for tactical implications: fighter opposition, flak density, formation spacing, rather than for isolated technical anomalies unless a pattern clearly emerged. Within the 458th Bombardment Group, the loss of 42-94917 was folded into monthly summaries under non-combat causes. However, maintenance officers at RAF Horsham St. Faith began noting scattered references to electrical inconsistencies in several B-24 aircraft returning from sorties over the North Sea. These reports were not uniform. One crew mentioned a temporary fluctuation in voltage affecting cockpit lighting. Another described a brief failure of the automatic direction finder. In each case, systems returned to normal before landing. Ground crews typically attributed the behavior to generator strain in cold, moist air at altitude. The Liberator's electrical architecture was complex for its time. Each engine powered a generator, feeding a shared distribution network that supported radios, navigation instruments, and certain hydraulic controls. A partial generator failure might leave an aircraft flyable while impairing communication or instrument reliability. The engineering manuals warned that prolonged icing could place additional load on engine-driven accessories. In early May, a board at group level convened informally to review maintenance trends. The Chief Engineering Officer, Major Clarence D. Howell, examined inspection sheets from February through April. He did not identify a common defective component, but he did observe that aircraft flying the coastal ingress routes over the North Sea were more likely to log minor electrical complaints than those assigned to inland ferry duties. The distinction was subtle and based on small numbers, yet it was sufficient to prompt discussion. The original crash of 42-94917 resurfaced in that context. Major Howell noted that no emergency transmission had been received. He asked whether atmospheric conditions over the North Sea could interfere with radio output. Signal officers explained that high-altitude ionospheric variations could distort long-range transmission, though complete silence from a descending bomber was unusual. Standard procedure required crews to attempt contact even during non-critical turnbacks. Complicating the review was the absence of survivors. Without testimony from the cockpit or radio compartment, reconstruction relied on fragmentary evidence. The propeller rotation marks, indicating engine power at impact, conflicted with theories of total power loss. There was also no indication that the crew had attempted to ditch parallel to wave direction, a maneuver taught during overwater training. Instead, the shallow descent observed suggested either controlled flight into the sea or a gradual loss of altitude without abrupt correction. In mid-May 1944, another B-24 from a neighboring group reported severe compass deviation while flying a similar outbound route. The pilot described the magnetic compass oscillating erratically for several minutes before stabilizing. The navigator relied on dead reckoning until readings normalized. The incident did not result in a crash, but it was documented in greater detail than earlier reports due to heightened awareness. At higher headquarters, 8th Air Force engineering staff received summaries of such irregularities. Their analysis emphasized environmental factors. The North Sea corridor was known for variable moisture layers and temperature gradients. Ice accumulation on antenna mass or static buildup along fuselage surfaces could affect radio clarity, yet no directive was issued to alter routing significantly, as mission priorities outweighed speculative concerns. Within the 458th Bombardment Group, some flight engineers quietly compared notes. One senior non-commissioned officer recalled that Lieutenant Givens had been meticulous about fuel mixture settings. He doubted that simple engine mismanagement would account for the controlled descent described by coastal observers. If multiple engines had failed suddenly, a sharper loss of altitude would have been expected. Conversely, if only one engine had malfunctioned, standard procedure would allow continued flight within formation, at least until clear of friendly territory. A review of fuel system schematics suggested another possibility: cross-feed imbalance. The B-24 carried fuel in multiple wing tanks. Improper cross-feed could starve an engine while leaving others powered. However, such a condition typically produced noticeable yaw and vibration. Formation pilots flying near 42-94917 had not reported abrupt deviations. They recalled only a gradual drift downward. In June 1944, with the Allied landings in Normandy underway, operational strain increased further. Aircraft were flown at a rapid pace, and maintenance crews worked extended shifts. Under such pressure, extended forensic inquiry into a March crash became unlikely. Nonetheless, a memorandum circulated within the group recommended closer inspection of generator, couplings, and voltage regulators during routine servicing. That summer, 2 additional incidents occurred involving B-24s turning back over the North Sea due to unspecified instrument anomalies. Both aircraft returned safely. Post-flight checks found minor corrosion in electrical connectors, attributed to persistent moisture exposure. The North Sea's maritime environment was harsh on metal components, particularly when aircraft were based on open airfields exposed to salt-laden winds. The question persisted: could corrosion or moisture have contributed to a cascading failure aboard 42-94917? If electrical output diminished gradually, radios might fail before flight instruments did. The crew might have focused on managing engine settings while unaware that communication was already compromised. Yet even this explanation did not fully address the controlled nature of the descent. Some officers considered the possibility of spatial disorientation. At altitude, with limited horizon visibility over water and cloud layers below, subtle instrument errors could mislead a crew. If the artificial horizon or altimeter provided inaccurate readings, a pilot might believe the aircraft to be level while descending slowly. The recovered altimeter housing from 42-94917 was too damaged to determine pre-impact calibration. Training manuals stressed cross-checking instruments regularly. Lieutenant Givens and his co-pilot had logged sufficient flight hours to be considered proficient. Still, no aircrew was immune to cumulative fatigue. By March 1944, many crews had been flying missions at frequent intervals. Long periods in unpressurized cabins at high altitude imposed physical strain, even with supplemental oxygen. Official doctrine maintained confidence in the B-24's design. While the aircraft had handling characteristics that differed from the B-17 Flying Fortress, it was valued for its range and payload. Engineering bulletins issued in mid-1944 addressed fuel vaporization risks and hydraulic leaks, but did not single out systemic electrical vulnerability. Without conclusive evidence, 42-94917 remained an isolated case in formal records. Privately, a few officers expressed discomfort with the undetermined designation. The absence of flak damage, enemy fighters, or weather extremes left a gap in explanation. Yet wartime investigation operated within constraints. Salvage from the North Sea was limited by depth and resources. Divers could not be spared for extended recovery operations when amphibious landings demanded attention elsewhere. By autumn 1944, as Allied forces advanced across France, interest in early-year incidents diminished further. Replacement aircraft arrived with incremental design modifications, including improved de-icing equipment and refined electrical insulation. Whether these changes were influenced in any small measure by earlier losses is difficult to establish. Engineering evolution in wartime was continuous and often cumulative. For the families of the 10 men lost aboard 42-94917, closure came in the form of official certificates and posthumous service medals. No additional clarification was offered beyond the original finding. The crash site remained marked only by coordinates in naval charts and scattered debris, resting beneath shifting currents. Among surviving members of the 458th Bombardment Group, recollection of the event persisted quietly. It was not cited in formal histories as a defining episode. It did not alter tactical doctrine or strategic planning, yet in maintenance sheds and crew briefings, references to unexplained electrical irregularities occasionally resurfaced when new anomalies appeared. By the end of 1944, with the war entering its final phase in Europe, attention focused on fuel shortages in Germany and the collapse of organized resistance. The loss over the North Sea receded into the background of broader operational history. It remained documented, reviewed briefly, and ultimately unresolved within the technical framework available at the time. In January 1945, with Allied air superiority firmly established over Western Europe, attention within the 8th Air Force began shifting from sheer sortie volume to efficiency and survivability. Losses to German fighters had decreased significantly, though mechanical attrition continued at a steady rate. Engineering branches at bomber stations were instructed to compile broader summaries of non-combat incidents from the previous year, partly to refine maintenance allocation and partly to improve training for replacement crews. At RAF Horsham St. Faith, Major Clarence Howell revisited earlier files, including the March 1944 loss of 42-94917. The renewed review was not prompted by new evidence from the crash site, but by cumulative maintenance data gathered over several months. Reports from autumn 1944 had noted intermittent failures in voltage regulators and generator drive couplings on multiple B-24 aircraft operating from coastal bases. Though none of those incidents resulted in fatal crashes, the pattern was sufficient to draw cautious attention. A technical liaison officer from Consolidated Aircraft visited several 8th Air Force bases in February 1945 to collect operational feedback on the Liberator systems under sustained European conditions. His interviews with engineering officers were structured and procedural. When Major Howell mentioned the March crash, the liaison officer requested access to the original maintenance sheets and fragment analysis. The review highlighted a detail that had received limited emphasis earlier. One recovered section of wiring harness showed signs of heat exposure, without clear evidence of external fire. The insulation was brittle and partially melted. At the time, investigators had attributed this to post-impact damage. The liaison officer suggested that prolonged electrical arcing before impact could produce similar effects, particularly if moisture had compromised insulation. Electrical arcing within confined spaces of the fuselage could disable communication equipment gradually rather than instantaneously. Radios might fade or cut intermittently. More critically, if arcing occurred near instrument wiring, erratic readings could result. The B-24's instrument panel relied on electrical input for certain navigation aids and cockpit lighting, though primary flight controls remained mechanically actuated. The possibility of a localized electrical fire was considered. However, no witness had reported smoke trailing from the aircraft. The RAF Coastal Patrol pilot had described a clean silhouette against the sky. A contained electrical fault might produce limited smoke inside the fuselage without external visibility. In such circumstances, the crew's attention would likely focus on isolating circuits, checking circuit breakers, and maintaining engine balance. Procedural manuals instructed radio operators to report any electrical malfunction immediately. The absence of a transmission from 42-94917 might indicate that the radio compartment lost power early in the sequence. If generators were compromised or if bus lines were damaged, communication could fail while engines continued functioning. Another technical element drew attention. Voltage fluctuations could influence the operation of the autopilot. The Liberator's autopilot, though not universally engaged during formation flight, assisted with altitude stability. If voltage irregularities caused intermittent disengagement without clear cockpit warning, gradual descent could occur before pilots recognized deviation. Over open water, with cloud layers below and limited horizon reference, subtle altitude loss might not be immediately apparent. The liaison officer emphasized that these were hypotheses rather than conclusions. Without substantial wreckage, definitive attribution remained impossible. Nonetheless, he recommended enhanced inspection of wiring insulation in high moisture environments and reinforcement of generator shielding. By early 1945, later production B-24 variants already incorporated incremental improvements in insulation materials. The question persisted as to why no abrupt maneuver was observed before impact. If Lieutenant Givens recognized a severe internal malfunction, standard training would call for either returning to base or preparing for controlled ditching. The observed shallow descent suggested either delayed recognition or instrument misinterpretation. Testimony from surviving formation pilots, recorded months after the event, indicated that 42-94917 had not displayed visible distress signals, such as flare deployment or erratic banking. One pilot recalled that the aircraft appeared lower than usual, but stable. He assumed the crew was adjusting position before turning back. A gradual electrical degradation affecting multiple systems simultaneously might create confusion without immediate panic. Pilots trained in mechanical redundancy often trusted engine sound and control feedback over instrument readings. If engines continued to produce power, descent might be attributed to minor trim imbalance rather than systemic failure. By March 1945, as Allied forces crossed the Rhine, operational urgency overshadowed retrospective analysis. The war in Europe was approaching its conclusion. Engineering recommendations based on accumulated data were distributed in technical bulletins, but individual cases such as 42-94917 were not singled out publicly. After Germany's surrender in May 1945, demobilization began. Aircraft were ferried back to the United States or scrapped in place. Personnel rotated home. Wartime investigative files were archived, often without comprehensive cross-referencing. The loss over the North Sea remained officially categorized as undetermined mechanical malfunction, though internal memoranda reflected tentative electrical hypotheses. In the immediate post-war years, the North Sea crash site was not subject to systematic salvage. The depth and currents made recovery impractical relative to available resources. Naval charts retained approximate coordinates. No formal naval board revisited the site with post-war diving technology. For the families of the crew, personal effects recovered months after the crash were forwarded when possible. A wristwatch, a fragment of a logbook cover, and portions of identification tags were among the items cataloged. These artifacts carried no technical clarification. Within broader historical accounts of the air war, the incident received little attention. Historians focused on strategic bombing debates, industrial impact assessments, and large-scale operational shifts. Individual unexplained losses were often subsumed within aggregate statistics. Yet among aviation engineers studying wartime aircraft reliability in the late 1940s, references to moisture-related electrical degradation in early B-24 models appeared in technical literature. Improvements in insulation materials and sealing techniques were documented as responses to field experience. Whether those refinements were influenced indirectly by cases such as 42-94917 cannot be established definitively, but cumulative wartime feedback shaped post-war aircraft design standards. The crash of 23 March 1944 thus remained suspended between partial evidence and informed speculation. It did not produce doctrinal overhaul or public inquiry. It was recorded, examined within practical limits, and ultimately left unresolved in formal conclusions. By the time surviving members of the 458th Bombardment Group gathered for reunions years later, recollections of the aircraft's steady descent over the North Sea persisted in subdued conversation. No new documentation had surfaced. No diver had retrieved a flight instrument to clarify final readings. The official record remained unchanged. The loss stood as one of many wartime incidents where mechanical complexity, environmental stress, and operational tempo intersected beyond the capacity of contemporary investigation to resolve fully. Its explanation rested on probabilities rather than proof, shaped by engineering inference rather than conclusive recovery. In the decades following the war, the crash of 42-94917 remained largely confined to archival folders and family records. The North Sea gradually yielded wreckage from various wartime losses as fishing trawlers recovered fragments in their nets, yet no substantial portion of the Liberator was positively identified. The coordinates recorded in 1944 were approximate, based on visual estimation rather than precise navigational triangulation. Over time, tidal movement and corrosion would have dispersed lighter components across a wide area. By the early 1960s, interest in wartime aircraft losses shifted from operational necessity to historical preservation. Aviation researchers began cataloging unresolved incidents with greater care. Among them was a British civil aviation historian who specialized in coastal air crashes. While reviewing RAF patrol logs, he encountered the entry describing a 4-engine bomber descending steadily without visible fire. Cross-referencing American records, he identified the aircraft as belonging to the 458th Bombardment Group. The historian noted the absence of a distress call and the lack of combat damage. He corresponded with surviving members of the group, collecting recollections that were consistent in tone but limited in technical detail. Most remembered the aircraft slipping below formation gradually. None recalled seeing parachutes. By that time, post-war analysis of B-24 design evolution was better documented. Engineers who had worked on later production models confirmed that improvements in wiring insulation and generator protection had been implemented during late 1944 and early 1945. Field reports from European bases had influenced those refinements. Moisture ingress and corrosion were acknowledged as persistent operational challenges in maritime climates. In the late 1970s, as underwater survey technology improved, a private maritime research group conducted side-scan sonar sweeps in portions of the southern North Sea. Their objective was to locate known wrecks for documentation rather than recovery. Among the sonar contacts recorded was a debris field, consistent in size with a four-engine bomber. The site lay near the estimated coordinates of the March 1944 crash. Due to depth and limited funding, only a brief photographic survey was conducted using a remotely operated camera. The images revealed scattered metallic fragments partially embedded in sediment. One component appeared to be a radial engine cylinder assembly. Another resembled part of a landing gear strut. The wreckage was heavily corroded, and identification markings were not visible in the available footage. No comprehensive salvage operation followed. Maritime law and cost considerations discouraged disturbance of what was regarded as a war grave. The site was catalogued but left undisturbed. For historians, the sonar survey confirmed the likely resting place of the aircraft, without resolving the cause of its descent. By the 1990s, renewed attention to unexplained wartime incidents emerged within aviation research circles. Scholars examining accident reports compared patterns across different theaters. Some concluded that electrical system degradation in early heavy bombers was more widespread than wartime summaries suggested. However, data gaps limited certainty. Many non-combat losses lacked sufficient wreckage analysis to distinguish between mechanical, environmental, and human factors. A technical review published in an aviation journal in 1998 referenced cases of gradual altitude loss linked to autopilot disengagement combined with instrument misinterpretation. The article cited no specific aircraft by serial number, but described scenarios in which voltage irregularities led to inconsistent instrument illumination and subtle attitude drift. The parallels to the March 1944 event were noted indirectly by researchers familiar with 4294917's file. Despite these retrospective interpretations, no definitive causal chain could be established. The surviving fragment photographs did not reveal conclusive evidence of pre-impact fire. Engine components showed deformation consistent with powered rotation at impact, reinforcing earlier observations that at least partial engine output remained until the final moments. For the families of the crew, the absence of clarity endured across generations. Archival requests occasionally produced copies of the original undetermined mechanical malfunction designation. No amendment was ever issued. The men were commemorated in memorials to the missing, their names engraved among thousands lost in European operations. Within military historical records, the crash became a minor reference point in discussions of maritime environmental stress on aircraft systems. It did not occupy a central place in strategic narratives, yet it persisted as an example of the limits of wartime investigation. The combination of incomplete wreckage recovery, high operational tempo, and evolving technical knowledge left certain events beyond conclusive explanation. In 2014, on the 70th anniversary of the loss, a small ceremony was held at a memorial site in England, honoring airmen lost over the North Sea. A representative of the 458th Bombardment Group Association read aloud the names of the crew of 4294917. No technical conclusions were presented. The focus remained on service and sacrifice rather than unresolved mechanical detail. Modern aviation analysts reviewing the available data generally converge on a probable scenario involving electrical degradation compounded by environmental moisture exposure. They note that a cascading electrical failure could impair communication, navigation aids, and autopilot stability without immediately silencing engines. In such a situation, a crew might experience gradual altitude loss while attempting internal troubleshooting. Over open water, with limited visual reference and cold atmospheric layers below, recognition of descent could be delayed. Yet probability is not proof. Without direct cockpit recordings or intact instrument panels, the final sequence cannot be reconstructed with certainty. The official wartime finding remains technically accurate. The cause was undetermined within the evidence available. The story of the March 1944 crash illustrates the broader reality of large-scale wartime aviation. Not all losses were the result of enemy action. Some arose from the interaction between complex machinery and unforgiving environments. Others reflected the limits of contemporary technology in diagnosing failure under combat conditions. The aircraft that left RAF Horsham St. Faith that morning did so under routine orders, with a trained crew and serviceable equipment according to inspection logs. It separated from formation over friendly waters without visible damage. It descended steadily and struck the sea with engines turning. Investigators documented what they could, inferred cautiously, and moved forward amid ongoing operations. What remains is a record shaped by restraint rather than certainty. The crash was neither sensational nor strategically decisive. It was a quiet loss absorbed within the vast scale of the air war. Its explanation lies within a range of informed possibilities, bounded by the evidence that survived and the evidence that did not.